Right now, as you're watching this, there's a cherry red sports car hurtling through the void of space at over 6,000 miles per hour. Behind the wheel sits a mannequin in a real spacesuit, his arm casually resting on the door, eternally cruising past Mars with David Bowie's Space Oddity set to play on repeat, though the speakers died years ago in the silent vacuum. This isn't science fiction. This is real. And the story of how a billionaire's personal vehicle ended up becoming the most distant car from any dealership in the universe is one of the most fascinating tales of modern space exploration. If you find stories about space, technology, and the audacious ambitions of humanity exciting, you're going to want to follow along. Because by the end of this, you'll understand not just why there's a Tesla in space, but what it teaches us about the future of human exploration. On February 6, 2018, something unprecedented happened at Kennedy Space Center in Florida. From Launch Complex 39A, the very same pad that launched Apollo 11 to the moon in 1969, a massive rocket roared to life. But this wasn't any ordinary rocket. This was the Falcon Heavy, SpaceX's newest and most powerful rocket at the time, making its maiden voyage. Standing 230 feet tall and generating over 5 million pounds of thrust from its 27 Merlin engines, it was the most powerful operational rocket in the world. And strapped to the top? Not a satellite, not scientific equipment, not even the typical concrete blocks that most test flights use as dummy payloads. No, sitting in the payload fairing was a 2008 Tesla Roadster, Elon Musk's personal car. The world watched as the rocket climbed through the atmosphere, its two side boosters separating and performing a synchronized landing back on Earth that looked like something straight out of a science fiction movie. Meanwhile, the Roadster continued climbing, eventually separating from the rocket's upper stage and beginning its eternal journey around the sun. The Tesla wasn't sent up empty. Sitting in the driver's seat is a figure SpaceX affectionately named Starman, a full-scale mannequin wearing an actual SpaceX spacesuit. This isn't a prop costume. It's a legitimate pressure suit, the same design that SpaceX astronauts wear during launches to the International Space Station. The suit alone costs approximately $200,000 to produce. Starman sits with one hand on the steering wheel, the other arm casually resting on the door, looking for all the world like he's out for a Sunday drive. Except his Sunday drive has now lasted over 7 years and counting. Follow along if you want to know exactly where Starman is right now, because the numbers are mind-blowing. The dashboard display, visible through cameras that broadcast the launch live to millions of viewers, reads a simple message: don't panic. If that phrase sounds familiar, it should. It's a direct reference to Douglas Adams' beloved science fiction comedy, The Hitchhiker's Guide to the Galaxy, where those words appear on the cover of the fictional guidebook that helps travelers navigate the universe. When you're sending a car into the eternal void, apparently you want to make it interesting, so the car is loaded with Easter eggs. Mounted on the dashboard is a Hot Wheels miniature version of the Tesla Roadster, complete with a tiny Starman figure inside. So technically, there's a car inside a car floating through space. A data storage device called an arch, pronounced ARC, contains Isaac Asimov's classic science fiction series, Foundation, a saga about preserving human knowledge across the collapse and rebuilding of galactic civilization. The symbolism isn't subtle. There's also a towel, another Hitchhiker's Guide reference, since in Adams' books, a towel is described as the most massively useful thing an interstellar hitchhiker can have. Starman is prepared. Etched onto a circular plaque are the names of over 6,000 SpaceX employees who worked on the Falcon Heavy project. Humanity left its signature. And printed on the car's circuit board are the words, "Made on Earth by humans," in case, millions of years from now, some extraterrestrial intelligence encounters a degraded sports car and wonders where it came from. The original plan was to put the Tesla into an orbit around Mars. But something went slightly differently. The rocket's upper stage burned a bit longer than expected, and the car overshot its intended trajectory. The result? The Tesla Roadster is now in what scientists call a heliocentric orbit, an elliptical path around the Sun that takes it from roughly Earth's distance from the Sun out past Mars and into the asteroid belt, then back again. Let's look at the current numbers as of 2025. The Tesla has traveled over 4.3 billion miles since launch. To put that in perspective, that's enough to drive to Mars and back over 30 times. The car's original 36,000-mile warranty has been exceeded by approximately 120,000 times. The Roadster has completed approximately 4.5 orbits around the Sun. Each orbit takes about 557 Earth days, meaning the car experiences a year. That's about 1.5 times longer than ours. At its closest approach to the Sun, called perihelion, the car comes within about 0.99 astronomical units, nearly Earth's distance. At its farthest point, called aphelion, it swings out to about 1.66 astronomical units, well past Mars' orbit. The website whereisroadster.com tracks the car's position in real time if you want to check in on our cosmic commuter. Go follow and bookmark it. It's strangely addicting to watch. Current speed? The Tesla is moving at approximately 6,700 miles per hour relative to Earth, though its speed varies depending on where it is in its orbit. When it's closest to the Sun, it speeds up. When it swings out toward the asteroid belt, it slows down. As of early 2025, the car has traveled far enough to drive all roads on Earth more than 72 times. Space is not kind to terrestrial objects. While Starman looks calm and collected, his vehicle is slowly being destroyed by the harsh environment of interplanetary space. Without Earth's protective magnetic field and atmosphere, the car is being continuously blasted by cosmic radiation and ultraviolet light from the Sun. This radiation breaks down the molecular bonds in organic materials. The car's carbon fiber body, leather seats, rubber tires, and plastic components are all slowly degrading. Scientists estimate that within the first few years, most of the organic materials would have become brittle and begun to break apart. The paint is likely faded significantly or flaked off entirely. That gorgeous midnight cherry red color exists now only in our photographs and memories. Depending on whether a part of the car is facing the Sun or shadowed, temperatures can range from approximately 250 degrees Fahrenheit to minus 100 degrees Fahrenheit. These constant thermal cycles cause materials to expand and contract, accelerating degradation. Space isn't as empty as you might think either. Tiny particles of rock and dust are constantly zipping through the solar system at incredible speeds. Over time, these micrometeorites are slowly pitting and damaging the car's surface. So what will be left? Scientists predict that within about a year, most of the exterior organic materials were destroyed. The aluminum frame, glass, and more stable metals will last much longer, potentially millions of years. The car won't disappear. It will become an unrecognizable husk, sandblasted by cosmic radiation and peppered with tiny impact craters. But its fundamental structure will persist for an almost incomprehensible amount of time. Researchers at the University of Toronto published a study calculating the car's long-term orbital fate. They found that the Tesla will likely continue orbiting the Sun for tens of millions of years before eventually colliding with something. The odds? There's about a 6% chance it will collide with Earth over the next million years, and about a 2.5% chance it will hit Venus. Mars and the Sun are also possibilities, though less likely. Don't worry. If it does eventually return to Earth, the timeline is so vast that humanity will either have solved that problem or won't be around to care. This is the question everyone asks. Why send a car to space? The practical answer is simpler than you might think. The Falcon Heavy's first flight was a test mission. Test flights are risky. There was a genuine possibility the rocket could explode on the launch pad or fail during ascent. SpaceX estimated roughly a 50% chance of complete mission failure. No paying customer would put an expensive satellite on an untested rocket. So test flights typically carry dummy payloads, essentially dead weight, to simulate a real mission. NASA often uses blocks of concrete or steel. Elon Musk decided that if SpaceX was going to launch deadweight, it might as well be entertaining deadweight. He had a 2008 Tesla Roadster sitting around, the first production car from Tesla, and figured launching it into space would be more interesting than launching a concrete block. He was right. The launch became a global event. Hundreds of millions of people watched the live stream. Images of Starman floating above Earth became instant icons. The publicity SpaceX received was worth billions of dollars in equivalent advertising. If you're enjoying this story about the intersection of space, technology, and bold vision, make sure you're following for more content like this, because we explore the stories behind the headlines that shape our future. But beyond marketing, there's something deeper happening here. When historians look back at the early 21st century, the image of a car floating in space with Earth in the background might become one of the defining photographs of our era. It represents something profound about human ambition. For all of human history, we've looked up at the stars and wondered. For most of that history, they were utterly unreachable. Then, for a few decades in the 20th century, we reached out and touched the moon before retreating back to the safety of low Earth orbit. The Falcon Heavy launch and its ridiculous payload represented a shift. Private industry was now capable of reaching beyond Earth orbit. The same rocket that launched a sports car could launch supplies to Mars. The same technologies that made this stunt possible are now being used to return astronauts to the moon and plan missions to the Red Planet. The Tesla in space is silly. It's a billionaire's publicity stunt, but it's also proof of capability, proof that humanity can reach the planets, and that we're actively working to do so. And there's something beautifully human about the absurdity of it all. We could have launched a scientific instrument. We could have launched a time capsule with solemn messages. Instead, we launched a sports car with a mannequin at the wheel and the words, "Don't panic," on the dashboard. If aliens ever find this thing, what will they think? They'll find evidence that humans not only developed the technology to escape their planet, but had a sense of humor about it. The Falcon Heavy has since flown many successful missions, carrying real payloads for real customers. It's launched military satellites, NASA missions, and commercial cargo. The test flight's success proved the rocket's capability, and the Roadster stunt ensured the whole world was watching. SpaceX has since moved on to developing Starship, an even larger and more ambitious rocket designed to carry humans to Mars. When those first settlers arrive on the Red Planet and look up at the night sky, somewhere out there, the Tesla Roadster will still be orbiting, a reminder of the audacity that started humanity's journey to becoming a multi-planetary species. As for Starman, his journey continues. He's now traveled farther than any car will ever travel. He's circled the sun repeatedly, passed within shouting distance, cosmically speaking, of Mars, and ventured into the asteroid belt. Every 557 days, he completes another lap around our star. He'll keep making those laps for millions of years, long after everyone alive today is gone, long after the company that built his vehicle has been forgotten, perhaps even long after humanity itself has evolved into something unrecognizable. Let's wrap up with some final statistics that capture the scale of this journey. As of 2025, Starman has been in space for over 2,500 days and counting. The total distance traveled exceeds 4.3 billion miles. The Roadster has completed approximately 4.5 orbits around the Sun, moving at speeds varying between 5,000 and 7,000 miles per hour relative to Earth. The warranty has been exceeded over 120,000 times. The estimated survival time of the car's structure is tens of millions of years, with about a 6% probability of eventual Earth collision over the next million years. And if the speakers still worked, Space Oddity would have played over 500,000 times by now. The Tesla Roadster floating through space is, in many ways, a perfect metaphor for the current moment in human history. We're at a turning point. The same decade that saw a sports car launched into orbit also saw private companies start regularly ferrying astronauts to the International Space Station. We've watched rovers land on Mars with increasing sophistication. We've planned returns to the moon. We're designing habitats for other worlds. Starman, in his eternal cruise around the sun, represents the bridge between where we've been and where we're going. He's a testament to human creativity, ambition, and yes, our occasional absurdity. Somewhere out there right now, beyond the moon, beyond even the orbit of Mars, a red car drifts silently through the void. Its driver gazes eternally forward, hand on the wheel, waiting for a destination that will never come. And honestly, there's something beautiful about that. If this story captured your imagination, if you want to understand more about the incredible developments happening in space exploration right now, hit that follow button. We're living through the most exciting era of space exploration since Apollo, and I promise you don't want to miss what comes next. Because if we can put a Tesla in space, imagine what else humanity can achieve.